This is part 1. What is the Veil Nebula and why does it look like that? We start with the key question. What is the Veil Nebula and why does it look like that? What is the Veil Nebula and why does it look like that? Orbital Dispatch. Episode 1 script. Welcome. The Veil Nebula is the remnant of a star that exploded roughly 10,000 years ago. What you're seeing in those images isn't solid matter. It's superheated gas, still expanding outward at hundreds of kilometers per second. Intro. This is the first episode in a short series on the Veil Nebula. We're starting with the most fundamental question. What actually is this thing? And why does it look the way it does? By the end of this video, you'll understand what those glowing filaments physically represent. Not just that they're beautiful, but what's causing them to shine, and why the structure looks so dramatically different depending on how you image it. Section 1. What is a supernova remnant? To understand the veil, you first need to understand what a supernova remnant actually is. When a massive star reaches the end of its life, it collapses and then explodes with extraordinary force. That explosion doesn't just destroy the star, it sends a shockwave outward into the surrounding interstellar medium. That wave carries an enormous amount of energy, and it travels fast. In the case of the Veil Nebula, the original star likely had a mass somewhere between 15 and 40 times that of the Sun. It sits in the constellation Cygnus, roughly 2,100 light-years from Earth. The explosion that created it is estimated to have occurred around 10,000 years ago, recent in astronomical terms. What we're seeing now is that expanding shockwave, still moving outward, sweeping up, and heating the surrounding gas as it goes. Section 2. How the shockwave creates the filament structure. So why does it look like fine, twisted threads, rather than a smooth, expanding shell? The filaments you see in images of the veil are the result of that shockwave compressing and heating thin sheets of interstellar gas. Where the wave encounters denser pockets of material, the gas gets compressed into narrow, glowing structures. The geometry of those interactions, combined with our viewing angle, produces the appearance of delicate filaments. The entire remnant spans about 110 light-years across. What we see as separate structures, the eastern veil, the western veil, and the fainter Pickering's triangle, are all part of the same expanding shell, seen from different angles and at different stages of that interaction. Section 3. Why it looks different in different wavelengths. Here's something that genuinely changes how you read these images. The veil looks completely different depending on which wavelength of light you observe it in. In hydrogen alpha, you're seeing emission from hydrogen gas that's been ionized and excited by the shockwave. That tends to trace the outer edges, the leading front of the expanding material. In oxygen 3, you're seeing doubly ionized oxygen, which requires higher temperatures to emit. That emission tends to sit slightly behind the shock front, deeper into the structure. When you combine these channels, the distinct colors you see in processed images aren't artistic choices. They're physically meaningful. The color tells you what element you're looking at, and, broadly, where it sits within the shock structure. Closer. The Veil Nebula isn't just a photograph that looks striking. It's a record of a violent event, written in gas and light, still unfolding 10,000 years later. Every filament is a physical process we can actually interpret. That's what makes it worth understanding properly. Next episode, we'll look at what the veil tells us about the life cycle of the material it's ejecting, and what eventually becomes of a remnant like this. Subscribe CTA. If this kind of grounded space science is useful to you, subscribing keeps more of it coming. See you in the next one. That is part 1 of what is the Veil Nebula and why does it look like that. In part 2, we explore the next key question. Subscribe so you do not miss it.